Good evening, everyone, and welcome to New York Metro Weather's long-range technical discussion. We promised you guys we would meet up again and create another video after the holidays to revisit the pattern and speak about where we are and how we expect the pattern to change and when, if ever, we're going to get into a pattern favorable for snowfall on the East Coast and in the New York City area. So before we get into any details, we're going to take a look at the current pattern, the way it is right now, and what's really preventing us from getting any type of snowfall or longer duration cold air. So we know we had a very, very cold air mass in place today, last night, and the day before that. And we look at some of the reasons why. The first thing you'll notice here, the first yellow circle right here is over Greenland at the Davis Strait and northeast Canada, and this is a large polar vortex, so a big trough. You can see what you're looking at on the left side here are the anomalies, so the departure from normal in the middle of the atmosphere. So it's a very, very large and anomalous trough, cold trough at 500 millibars in the middle of the atmosphere, and this is a piece of the polar vortex which is sitting over Greenland and the Davis Straits. So as you can imagine, there's a lot of cold air bottled up here, and whenever you get a trough moving through the eastern U.S., it's going to dip down, give us some cold air, and then move out of the way. Why is it moving out of the way? Well, the reason is, out here in the Atlantic, you can see this is a ridge. This ridge has been flattened by the strength of the polar vortex, so it can't move to the north and west and create a block. And a block is essential. This block needs to be north over Greenland with the polar vortex a little further south for us to have sustained cold air. Otherwise, it's very transient. It's in and out very quickly. You'll notice there is also a ridge over the northwestern United States which is promoting some colder air coming into the eastern United States, but whenever the cold air is in the area, it's going to be mostly dry, and then as the trough lifts out, without the block, warm air can flood in and we can get precipitation events. Also notice over the Aleutian Islands in Alaska, another big trough which is also unfavorable for snow on the East Coast. So that's where we are right now. We have transient shots of cold followed by a warm-up and then precipitation events. Here is where the GFS goes from here. We look moving forward from now to about probably I'd say 10 days from now. So this is January 13th. We're looking at the GFS Ensemble forecast. Obviously, if you look to the right, you can see each ensemble member. There's a lot of variance here, but that's what the means here on the left are for. They can show you the anomalies and how they have changed. So let's look at what has changed here. Departure from normal. That big polar vortex over Greenland is still there, but not as strong as it was previously. And you can see now over the Atlantic, more ridging is building in towards Greenland. It's not quite there, but it's improved from where it was. There's also a big trough over the eastern United States. There we are right there, the little blip on the map. We realize it could be a little tough to look at the global map here, but you can really see the global wave pattern well here. So a very anomalous trough on the models. Still a ridge out west, which is supportive for this big latitude trough. Look how big this trough is here. Actually an extension of the polar vortex here over the eastern United States, modeled for the second week of January. And then notice the big trough over Alaska is replaced with a ridge. This is very important because forecast models are beginning to pick up on this ridge, which is going to form in the Pacific Ocean, extend towards Alaska, and then is actually forecast to build towards the pole and western Greenland, which is a very, very anomalous ridge. And that's the first sign of a pattern change. So we have a bunch of signs actually here for the pattern change. One, the ridging in the northwest Atlantic, the polar vortex still hanging on, but notice how things are improving in the Pacific for snow. And as we move things forward, you're going to see even more improvements. So this is towards the very, very tail end. Obviously, very much variance here you see on the right. But a few major features are becoming apparent. One, the polar vortex that was over Greenland has shifted to central Canada. Notice how even at this distance, I mean, we're now almost now to January 20th on this forecast model. Notice how strong the departures are here. You look at this as 3 shades in, so we're 12 to 18 decameter departures. So there's pretty good agreement here amongst the ensembles that there's going to be the polar vortex will have retrograded here to central Canada, and the reason for that is the ridge over the Pacific that is now extending towards northwest Greenland and the North Pole. This ridge really If you're looking for snow, you'd rather see it on the other side of the pole here towards northern Canada with the polar vortex displaced underneath it. But this is definitely an improvement, and to say that the pattern is changing on all the forecast ensembles is not far-fetched. It's not unfathomable to say the pattern is changing. It's definitely changing. It's a matter of how it's going to change that will determine whether or not we'll get snow. So when things are getting a little complicated here, we're going to dive in a little more, but we'll keep it as simple as we possibly can. Part of the reason why the pattern is changing is stratospheric warming, which is warming from the top of the atmosphere down. So we're looking at 5 HPA, 5 millibars. These warming events start above 30 millibars, which is high, way up there in the atmosphere. And we need to watch them carefully. So you can see this is called a sudden warming event. It's not technically defined yet as a sudden stratospheric warming because it hasn't really propagated down to the middle of the atmosphere yet. But these sudden stratospheric warming events are very important because they can change the pattern. They can move these vortexes, and the big vortex over Greenland, which has inhibited our winter weather, or any winter weather in the northeastern United States for that matter, any snowstorms, will be split or moved into a different spot, likely not where it is right now, if this warming event does come to fruition. So the one thing that hasn't happened yet is this warming, which you see occurring here at 5 millibars, so the very top, just the very beginning of it, has not downwelled yet. It's not moved. The downwelling has not occurred from 5 into more important areas like 50 millibars and 70 millibars. And we'll take a look at those charts in a minute. But here's the 5 millibars. We'll take a look, and you can see a few things important here. Towards the middle of December, we were below normal. We were below the mean, which is the green dotted line. And now you can see the sudden warming which has occurred, bringing us to the first day of the year here. January 1st, 2012 was when we pulled this graph up. And you can see we're actually nearing records from 1979 to 2008. We're very close to that. So there's no two ways about it. You can see it on the charts. It's very easy to see plain eye the temperature. This is a sudden warming event beginning at the very top of the atmosphere. So now we have to watch and see has that downwelled. We'll go to 10 millibars. And you can see here also the sudden warming. We're missing a little bit of data here, but you can imagine where the line has gone. It's weakened a little bit. You'll notice that it's moved down. But these things do come in waves. Sometimes it happens all at once. Sometimes it'll happen in one wave and it'll jump back up again. But you can see we're above where we were at this point last year, and we're actually in the 70% to 90% of the max of the mean. Now, we're going to take a big jump here. So we're at the top. We were looking at 5 and 10 millibars, and you say, okay, that's good. We're beginning. Has this downwelled yet? Has it moved down to 50 and 70 millibars? And the answer is not to the extent that it did at 5 to 10. So we haven't seen these changes yet. You can see here's the warming event that we saw at the end of December. It did get us back towards the mean, but now we have sunk down again at 70 millibars. So we have not seen the downwelling that we want to see in order to really start seeing these changes at 500 millibars and start seeing these fundamental changes in the atmosphere. So this is not to say that we aren't going to see another event, but really what we want to see if we want to get this pattern to really change is to get these 70 millibar changes to occur, and then things will be able to change. You don't get these vortexes to move if you don't get the stratospheric warming events to downwell. That's the point we're trying to make here. But it is definitely a good start. 5, 10, 30 millibar. You can see the very dramatic changes that have occurred there. And we'll just be watching. Here's another look. This is I think we looked at 5, 10, and 70. This is just to give you a global look at the 50 millibar temperature anomalies. The top image is from the 5th of December, so the beginning of December. You can see very cold anomalies over the northern hemisphere, Canada, Greenland, Davis Strait up here into the Aleutians even. And now the 1st of January, look how much things have changed in a month. So there's definitely something going on up there. Things are beginning to swing around here. And the atmosphere is so complex, and things change over time. So even now, we have this event now down to 50 millibars, which is good. It's a good start. But it could be another 2 to 3 weeks before we start to see these effects being felt on the pattern. What effect could this have on the pattern? We'll look at the European model from today, an outlier solution, but definitely a possibility. We'll take a look here. What could happen down the road? And you can see there is a ridge building towards the Aleutians in Alaska. That's one anomalous feature. And there's another one moving towards Greenland in the North Atlantic. Those two features, blocking features, forcing a trough underneath over the northeast of the United States and the East Coast. And you can see very, very impressive negative anomalies here at 500 millibars over the East Coast of the United States. So these two features, ones to watch as you're moving forward. When you have positive departures from normal at 500 millibars over Greenland and over the northeast Pacific, pardon me, you can get pretty dramatic results down towards the East Coast, and these things can occur very fast. But as we said, I think it'll be more of a step down process towards a more favorable pattern for snow. That's one thing that we need to keep in mind. And the last image we'll look at is the GFS ensembles moving forward, centered around January 15th. This is likely, this is one thing to say about this image before we really look at it too much, is that this has been adjusted by the analogs which came up on the GFS. So it looks at the pattern and says, okay, here are the analogs, and then it adjusts this image for the analogs. But you can see what potential this stratospheric warming event has when it downwells. You can see the big ridge over the Aleutians building towards the pole, and then another separate ridge over Greenland, positive height anomalies, which then forces Arctic air underneath in a more favorable pattern over the East Coast of the United States for snow. So these are things we need to keep in mind. To sum things up, we don't think the pattern change is going to affect us right now. So I mean, when you look at this video and you say, okay, maybe there's going to be snow right now, that's not going to happen. We're not going to have snow this week, and probably not next week. We're not going to have any big events. What we are trying to say is that the pattern change has been set into motion by the stratospheric warming at the top of the atmosphere, and we have to watch carefully how the downwelling occurs, where the polar vortex reestablishes itself, and how the Pacific and Atlantic respond. Will we get blocking here near Greenland? Will we get blocking here near the Aleutian Islands? Or will we not? This is what we have to deal with when we're changing the pattern from something so unfavorable and trying to look and see, hey, is it going to get more favorable for snow on the East Coast and in our area? It's a really intricate atmospheric process, and it's very humbling, really, as a forecaster, to try and figure this out. So we'll be watching over the next few weeks. Stay in touch, and we'll surely keep you guys updated. We'll talk to you soon.